What if I told you that you can turn on and off a load, a fan, a heater, or a door, or a system, or control a servo motor over 13-mile range or 21 kilometers for free, off-grid, without SIM card, without Wi-Fi? Yes, you heard it right. That is possible with LoRa. In this video, I'm going to show you how we can use the Heltec WiFi LoRa 32 module packed inside Meshnology N33 case with 3000 mAh battery for long-lasting performance and longer transmission and reception time. I'm going to show you the wiring, explain the code, and how to set this up so you can control your device over 13 miles for free. Sounds exciting? If you haven't subscribed to my channel, please hit the subscribe button and let's start with something awesome. In this tutorial, we're going to explain WiFi LoRa 32. Then we see how we can control a servo motor. The code will be explained. The wiring will be explained. And then I'm going to demonstrate it in the lab. And I'm going to demonstrate the LoRa version 32 up to 13 miles. So what is LoRa? It means long range, LoRa, long range data communication. You don't need any fee, you don't need any license for it. And in the US, the frequency is 902 to 928 megahertz. This module is LoRa Wi-Fi 32, and it is integrated with LoRa for long range communication, Wi-Fi, and Bluetooth, and it's full microcontroller like Arduino. In this case, we are using N33 casing from Meshnology, where we have this LoRa 32 module inside it, and when you purchase with a battery, you will have 3000 mAh huge capacity for long operation and more power and range in terms of transmission. So everything will fit in compact case. Now for this project, we use N33 with rotary encoder. So when we rotate it, we set the angle of our servo, and then the transmitter will transmit only when the value changes. So in this case, the transmitter is transmitting. This is the transmitter. And then we have the receiver, which receives the signal. The receiver will receive a signal, and it will control a servo motor. Keep in mind that in our project, the output from this module that I took is 3.3 volts, but the servo motors need 5 volts, which I'm going to show you the wiring. You need external 5 volts battery or power to power this up. And I use, for this purpose, I replaced the original antenna, and I use the high gain antenna that you can purchase from the link below this video. These are the dimensions for the antenna. In this video, we are going to use the Meshnology N33 case that comes with 3000 mAh battery and the Heltec WiFi LoRa 32 module, where we will connect so when we rotate the knob, we will set the angle. As the value changes, this will transmit the value securely up to 13 miles in direct line of sight, which I am going to demonstrate and show you. In the densely populated area with the buildings, I've tested it can work up to 1 mile or 1.4 kilometers, so we can send securely the data. And because we have N33 case and 3000 mAh battery, this is a compact case. You can carry it, and you can power this device perhaps to days when you set it as a transmitter and also maybe as a receiver, whatever way you program it, so it can last longer and more power for the transmission. And if you use high gain antenna, you will also increase the range. Then we are going to use another module, the same module as a receiver in this case, and I've attached here a servo motor just for demonstration purpose. So when we change the value and send the angle, the servo motor will rotate on the other end up to maybe 13 miles or 5 kilometer, 10 kilometer, whatever range you want. You can set the angle with the exact location, and also I've set and programmed this with a home button, so when I press it, it just rotates to the home position that you set in the code. Now, because this servo motor needs 5 volts, and from the back of this I've attached wires for the pins to control, and also I got 3.3 volts, so the servo cannot be powered with 3.3 volts, so you need external battery. For that, I use this module that gets the 18650 battery and will convert it to 5 volts, provide 5 volts via USB, or from the connectors here, which I'm going to show you this module fully. And we are powering our servo motor. We're just feeding the signal from the module so we can control the motor. It's a very exciting project. It has multiple applications. This is Meshnology.com. The Meshnology is website. They have tons of products that you can purchase from. This is N30 that we did a review. And here we have N32 and N33. Let's click on it. This is where you can purchase the N32 or N33. This N32, you see the corner is different with N33. Let's click on N33. There are different packages available here in terms of color or package, battery, module, the green version. I'll provide you the link if you want to purchase it from here or from Amazon. And here is the Meshnology Amazon store. You can get a single case only or different colors, and the case with all these components with LoRa Wi-Fi 32, 3000 mAh battery with flexible antenna and cable, and you can buy 2 cases with all the components with different colors, so different options are available for you to purchase. The link will be below this video in the description. Here is a package. When you purchase it, it arrives like this. I purchased the green casing with all the hardware. This is 3000 mAh battery, which lasts very long. And this is the LoRa 32. The actual module, hard antenna, extension for the mount, we can mount it on the box, flexible antenna, pin headers, and external battery or power supply if you want to power this module. To put this together, we need to first connect this into this. We need to connect this extension antenna connector. Just goes aligned with the line, so you don't need to even hold it when you tighten it. Let's see if the antenna goes here, how much room we have. So we have room to put all the nuts. all the washers. First put this washer, then the spring washer, and then the nut. Now let's connect this one, remove this antenna. Get this hardware. We insert these two push buttons. One is round, one is a little squared. Connect this screw here to hold the board in place. Now it's pressing it. Now let's place the battery. The wires are, the antenna wire is there, I'm placing it. Do not worry about this. For this connector, on one side you see a small bump. This bump goes at the bottom. Powered up. When I place it, there is no issue with the spacing. Perfect. Now, in order to connect the wires, let me put the keys so you can see we have to have the wires from this hole. I've cut this pen header according to the length of these holes. We're going to attach it. Let me disconnect the power. So if we place the pen header here, let me just insert it for you to see. And then if we put the cover, see, we need to create a hole in this area so the pen header is accessible. Now I've inserted the pen header and soldered the first and last pin to see it is now holding, but if we solder the rest, the pins are sticking out. We need to clip them with this tool. Okay, I've used soldering iron and inserted so it created the hole. As you can see, it's not fitting, but still I need to clear all these melted plastic. All of them should be just clipped. So I've clipped them out as much as I could. Let's just put it back in the case and see if it fits properly. Let's see. And here I'm inserting it, and let's see, align it properly. It's not going in. What is going on? So it seems I've not aligned it properly. If we look at it from this side, it seems that the hole that we have created should be a little towards the edge. So we need to create now, make it larger. Okay, I created more. I increased the width of the hole and cut it. Let's see. I think it's fitting properly. A little not aligned. It seems it needs to go a little further to the left. And after final adjustment and increasing the width of the hole, it seems now it's fitting perfectly without any issue. And here is the wiring for the rotary encoder, just connected the way it's shown. And here's the wiring for the servo motor as shown here. As I showed you the wiring, here is the actual wiring. When I hold this like that, from this side I'm connecting the right pin to the right pin, the second pin to the second pin, and these three will go. And here I've done the wiring according to the wiring diagram that I've just shown you. Very important to pay attention to this common between battery and this device. This point must be common. The wiring for the receiver is prepared like this. Strong, and I cannot add knot at the back. So here, you see the red is now on the way. So let's push it back. Let's see. Now this looks fine. I just need to insert the screws. I'm not going to tighten them because I just want to just disconnect and connect if I need it. I used soldering iron to melt this. I just insert it and hold it, so it created space. This works now, perfect. Apply these tapes So I can easily just peel it and disconnect the power if I need it. Now let's check the voltage between red and black. Red is connected to the white. So let's measure. It should be 3.3 volts. Yes. This is Kiwit's multimeter. I've done the review. The link is below the video in the description. I attached the servo motor here, and I have these wires which gives 3.3 volts ground and signal. This is a signal wire, but this needs 5 volts. For that, I'm using this 18650 5 volts converter. So this is 4.2 volts, actually 3.7 volts nominal voltage. When I put it, I can charge it from this micro USB. This is the input charging it, and it will give you here 3.3 volts, 3.3, 3.3, 3 ports here, and also 5 here, and also 5 volts out from USB. Get the 5 volts from here and feed this to the servo motor. Let's go with the ground and 5 volts. So as you can see, we are getting 5 volts, and also we can get 3.3 volts here, 3.1 volt, but also 5 volts from here to charge or whatever you need, a USB, and also you can power it off. You can buy that. So the battery will be charged via micro USB in this module, and then you can get the two of this for longer, larger capacity, longer operation, and it has USB-C and micro USB. There is a 4 battery pieces the same way, micro USB and USB-C, so you can charge them. I will provide you the link below this video. From the resource page you can purchase them. Some duct tape to attach this. This is now being held for demonstration purpose. So let's check this. Now I've attached this wire, making sure it's 5 volts. So it is 5 volt. Goes to the left. 5 volts goes to the middle always for the servo, so you do not make mistake. Now we just need one wire. So let's put some paper tape to hold it. And we need to connect between the system and the battery. We have to have a common ground. This ground, and I'm going to connect it anywhere that is here. We have ground, and it's rotated now. In order to work with Heltec WiFi LoRa 32 board, you need to install certain software on your Arduino IDE. First, we need to install the ESP32 boards, which is needed for any ESP32 board. Open your Arduino IDE. You can get it from arduino.cc. This is a free software. Go click here, boards, and then type ESP32. Here it says ESP32 by Espressif, and you will see here install button like that. Click on the install, and that will be done. Then we need to install certain software for Heltec. First, we will install ESP32 package. I will provide you this URL here, the JSON URL, which you can get it from Heltec documentation page under the ESP32 series. You right click and copy it. I will provide you the link. On Arduino IDE, click File, Preferences. This area is for additional boards. click to open it so we can see there is nothing. If you see another line, just at the end of the line, click and go down, and then right click and paste, and click OK, and click OK. Wait for this to complete. Click on boards and type Heltec ESP32. You will see it here, and this button would be install. Click on it to install it. Then we need to install ESP32 extended library from Heltec. Now click on library. This was board and this is library. Click on it and type Heltec ESP32. And you will see here it says Heltec ESP32 dev boards. You see it says remove. If you have not installed it, you will see install button. Click and install it. Then we need Adafruit GFX library for the display. Come here, click on library and type Adafruit GFX library. And here the first one, Adafruit GFX library. Click install. It says it needs dependencies. Click install all. Wait for this to complete. So we need to also install ESP32 Servo for the receiver. Click on this button and then ESP32 Servo. It's all one word, and this is the one by Kevin Harrington and John K. Click and install. I've installed the latest version 3.08 and it will be done. And then we need to install this library. Go here and then type AISP32 rotary encoder, and this is the one, the first one, because you don't see AISP32, and you will see install button. I've installed it and it's done. Make sure the board is selected. If not, click here and select board and type here V3. You will see Heltec LoRa Wi-Fi LoRa 32 V3. You see another kit is there. This says without LoRa, so select that, and then you should see the port. Select and click OK. Now let me explain the code. This is the power for the transmitter. We need to set this with a maximum. We can go up to 20. With a battery, it's better to go with 14, but let's say I'm going to set this to 14. This is the text that is shown on the screen, angle. The home position is the initial position. We can set it between 0 to 180 degrees. And this is for the switch pin, pin A and pin B of the rotary encoder. This is the angle step. Leave it at 6. This is for debugging, if you want to see the information on the serial monitor once it is connected. Right now I have connected it. If I open the serial monitor, you see this information. I'm rotating now. And this is the security key. Change it accordingly. Make sure to keep the double quotation. This is the frequency for the transmitter and receiver. You must set the exact same number, but make sure this cannot go depending on the region. In North America, we can go up to 928 and 432. The rest, you do not need to change anything. Once you did all the setting, just click here to upload the code and wait for this to complete. And here is the code for the receiver. This is the text that is displayed on the screen, this value, angle, and then home position. And this is the pin that we are connecting to the servo. This is the security key. This must match with the transmitter, exact value, and come here, set the frequency. And this is the TX power here. because we are using this for the receiver, so this does not matter. Once you did all the setting, just click here to upload the code and wait for this to complete. Here is a demonstration for the transmitter. It's connected fully and ready. So if I turn this, it's rotating. If I press this button, it sets it to the home page when I press this, it goes to the home position automatically. So here, this is the receiver. Receiver is ready. And I'm rotating this. And the servo is rotating. So I can rotate it slowly. As you can see, it's rotating 1 degree. But if I rotate it faster, it is rotating. And if I press this, it can go to home position. 90 degrees, it goes back to 90. Now, when I rotate it to the right, it goes to the left. When I rotate it to the left, it goes to the right. Simple. Either in the code, you can change the A and B pins or change the wire here. Because this is simple, I'm going to do the wire here. The last pin, the last wire here on this side is for the switch. So these two are A and B. So I'm going to bring B to E. And A to B. Now press it home, go to the right. Now it goes to the right. As you rotate it faster, it accelerates. It has acceleration feature, so you don't have to wait for 180 to go too far. Home. So perfectly, it works. Also, we can control these metal gear servos, digital one. Now the code is being uploaded. As you can see here, I set the debug to true. The serial monitor is ready. Let me increase the size if I could. So now I'm rotating this. As you can see here, we see the value is changing. And this is the value of 89, and this is the encrypted value that we are sending. Every time you change the value, the number increases. It says TX done, so it's sending the data. Here, also we can read it. And if I press this button, it says detected, and it sets it to 90 degrees. 180, and it will stop, or it goes to 0. Now, this is my setup. This is the transmitter with an encoder here, and as we rotate it, the number will change. And this is the receiver receiving, and I will walk with this away. So I put high gain antenna here. I'm going to put high gain antenna. I'm going to hold the camera. I ask my friend here to change the angle, and I'm going to show you the distance. Now I'm 1 kilometer away from the transmitter. Let me show you. So first, here is the distance, 1.2 kilometer at the point that I am. Can you set the signal to 45 degrees? Okay. Can you go for 120 degrees? Okay. Can you go to 0 degrees?
How much?
0.
Okay. Now it's 0.
Okay. Can you go back to home position? Excellent. Now I'm 1.4 kilometers away, as you can see here, and my house is somewhere on that direction. There is some valley or something and a lot of houses, and behind some houses is my home, and it shows 108 degrees. Can you set it to home position? Excellent. Can you change it to 0 degrees? Wow. Okay. Go to home position. Excellent. 90 degrees. Go 180. Guys, as you can see, it goes 1 degree, so 179. Excellent. Now go again home. Excellent. So guys, it's unbelievable. It works perfectly. I just used the high gain antenna with this Meshnology case. This case with 3000 milliampere hour battery inside it will make it last longer, like days. Not 1 day, perhaps 3 or 4 days. I've not tested it and I've not waited, but at home I had one with 1000 milliampere hour. It was running for more than a day. Now this is 3000 milliampere. And now this is 3000 milliampere hour, so it will run for days as a receiver. Even for the transmitter, the other one, perhaps it will last a day or maybe more with this Meshnology case. This is amazing, compact. I added all these other stuff to make the servo work, but now you saw the test in the lab. You will be wondering how this will work with a long range. I have used the same Heltec WiFi LoRa 32 module packed inside Meshnology N33 case and the 3000 milliampere hour battery, exact setup, while transmitting the voltage. The process, specification and setup is exactly the same. Instead of sending on and off signal, we will be sending angle. In order to avoid repeating, I'm going to show you the original video for sending the voltage so you know how it works. Now to get started with the range test, I'm setting this power to 20. When I work here in the lab, it will be 2 because we don't need, that's the lowest, and I can go 21, but I'm going with 20 to test it. For the transmitter code, you must select your security key, which must matches with your receiver. You use the same code, you can change it, and this is the frequency that we set. So these two must match, and then set the power that you want. Here The test is performed in this area on the lake because there is no obstacle on the path and it's direct line of sight. We place our transmitter here, and it's almost about 10 meters above the water level. And as you can see, there is no obstacle on the path because we avoided all this, and it's about 13.04 mile or 20.98 kilometers, which is almost 21 kilometers. Let me show you my setup for range test. I've placed here a camera. Transmitter is installed on a tripod, and it's connected via these wires down to the battery, where we can reach up to 30 volts of the voltage. I've set this up by the lake, and we are transmitting it about 5 to 10 miles or even more. I'm going to see how far this can transmit. We're going to transmit the signal on the other side, and we're going to see the voltage that's being transmitted, receiving it on this receiver, and I'm going to show you on the Google map to see how far we are. I've left the transmitter there and then walking towards my car to drive to the further destination so we can receive the signal. I'm 13 miles, which is about 20 kilometers away from the transmitter. Here my map is showing it. I hope you can see it because it's a bright sun, and the voltage is now on the screen. So I've called already my friend on the other side. So I'm gonna ask my friend to change the voltage. Please change the voltage.
Okay.
Okay, so as you can see now, we see about 9.71 volt and 13 miles. Amazing. This is unbelievable. So we are 20 kilometers away from that direction where the antenna is pointing, and we are receiving signal. So for conclusion, I would say if you want off-grid communication, sending and receiving information, monitoring devices or something, Wi-Fi LoRa 32 is the best option, very cheap. The link to purchase any of these components are below the video in the description. I have a resources page with all the photo, wiring diagram, everything, and the link will be below this video. If you purchase any product from those links, I'll get some commission. It will help me as well. Thank you.